Hey everyone, welcome back to Code of the Row. Today we're diving into the ultimate C++ beginner's guide to programming. In this video, we'll cover everything from A to Z that you need to know to jumpstart your programming career. So if you're ready to learn C++ from scratch and see where this incredible language can take you, stick around because we've got a lot to cover. Let's start with the basics. What is C++? C++ is a high-level programming language that's widely used in software development, game development, and system programming. It's known for its efficiency, flexibility, and performance, making it perfect for developing large-scale applications. C++ was created in 1983 by a guy named Bjarne Stroustrup at Bell Lab as an extension of the C programming language. He wanted to combine the speed and power of C with new features to support object-oriented programming. Today, C++ is used by some of the biggest companies in the world. So in the US, the average salary for a C++ developer ranges from $100,000 to $120,000 per year. However, this can vary widely on your experience level, location, and the industry you're working in. In tech-heavy areas like Silicon Valley and New York, salaries can easily exceed $150,000 a year. There will always be a need for C++ developers. Alright, now that we know what C++ is and why it's a great choice, it's time to get hands-on. To start coding in C++, we'll need an integrated development environment, or IDE. An IDE is a software application that provides all the tools you need to write, test, and debug your code. So for this video, we'll use Visual Studio Code, a popular lightweight and easy to use IDE. So first open up your web browser and let's head to code.visualstudio.com. And you'll see this giant download button which says download for Windows, and we'll just go ahead and click on that. And I'll just go ahead and install the application here. And now make sure you accept the license agreement, hit next. I'm going to create a desktop icon, make sure add to path is checked, and hit next just to install it like so. And now once it's done installing, let's go ahead and launch it. And now from here, after downloading VS Code, we're going to click on this C++ over here and click on this dropdown. And you can select whichever operating system you're using. And for my case, I'm going to click GCC on Windows. And now for the prerequisites, one of them is install Visual Studio Code, just like we did, and then to install the extension, which we'll get into as soon as we launch Visual Studios. And then after this, we actually need to install the min-gw-w64 toolchain. And this will work as our compiler so we can actually run the code. So let's go ahead and click on this link to download the installer, and I'll click save. And I'll just go ahead and proceed with the setup. So I'll download it right here. It's going to install that msys64, and I'll click next. And after it's done installing, make sure this run msys2 is checked and click finish. It'll launch a little command prompt, and all we need to do is just copy paste this into the terminal. So I will just copy this line here, and then I will right click and paste this and hit enter. It'll say enter a selection. Hit enter again, and then it'll say proceed with installation, Y or N, just type in Y and click enter. And after it's done installing, I just want to add this msys into our path. So I can exit out of this, and in Windows, I can just look for environment, and it'll say edit the system environment variables, and I'll select this. And after the system properties launches up, you'll see this environment variables in the advanced tab like so, and click on environment variables. And this will just show a bunch of variables, and we just need to add this simply over here. And it's already going to give us what to copy paste in. So I can just copy this line like so. And now in user variables right here, I'm going to click on path and then click edit. And I just want to copy paste this path simply by double clicking on a bottom one and then just paste this in and hit enter. And then I'll click OK, and I'll click OK again, and I'll hit OK, and I'll hit OK again to exit out of this. And now I'll hit my Windows key and search for CMD to open our command prompt. And while this is open, all I need to do is I'll type in gcc space -- version, and it'll give us a version. So it says 13.2.0, and it pretty much just says this is a free software, blah, blah, blah. This just means that we have the GCC installed. And now let's actually get into Visual Studios and begin writing our code. And after installation, when you launch Visual Studio Code, the first time you open it, you'll probably see a welcome screen. We're going to make a few adjustments to set it up for our C++ development. So let's head over to the extension tab on the left over here, where we see these 3 blocks and a 4th block coming out. And let's install the C/C++ extension by Microsoft. So I can just search for it and just look for that C++ or C/C++ like so. And you'll be able to install it by clicking the install button here. And we'll see that it's from Microsoft, and it even has a verification badge and verified domain over here. So this extension will give us syntax highlighting, IntelliSense, and other helpful features to write C++ code. We're all set up to start coding in C++. Writing your first C++ code. All right, let's get started. So up here, I'm going to click on this Explorer icon and I'll exit out of this extension tab like so. So now on my desktop, I'm just going to right click and create a new folder and I'll just call this my first program like so. And I can just drag this folder over here just to open this folder in Visual Studio. So I'll select new file and it'll pop up a little window where we can select file type or enter file name. I'm going to call this hello world. And because this will be a C++ type file, I'm going to type in .cpp. C++ files have an extension tag called CPP, which stands for C++. So I'll hit enter and I'll just save it into the my first program like so, and I'll hit create file. And I can exit out of this window tab like so. And now you'll see that it displays the title of our file here, hello world, and then .c++, and you'll even see a little C++ icon here to let us know that this is a C++ file. So now let's actually begin by writing our first C++ program. So now let's write our first program. In programming, the hello world program is a traditional way to start. It's a simple program that prints the message hello world on the screen. So let's type this together. So now I'm going to begin by typing in hashtag include, and then in the less than sign, I'm going to add a less than sign and type in iostream. And since I have a spelling mistake, I didn't write stream, I wrote steam. I can just click on this to fix the mistake and it'll automatically add this ending tag, which is a greater than tag. So let's talk about what this line does. The hashtag include iostream is called a preprocessor directive. It tells the compiler to include the contents of the iostream library into our program. And the iostream library is essential for input and output, hence the I and O. And this library is essential for our operations, such as displaying text on the screen, which we're about to do. And now let's write the main function of our program. So I'm just going to click enter a few times to create some space, and I will do int and main in parentheses, and then I'm going to open it up with a curly bracket. And you can get these curly brackets simply by holding the shift key while pressing the key on the right of shift. So now let's talk about the int main. So this line defines the main function. In C++, the main function is where the program starts running. Think of it as an entry point to your program. Whenever you run a C++ program, the first thing it looks for is this main function. Now let's add a line inside the main function to print some text to the screen. Inside my main function, between my curly brackets, I'm going to type in std : cout. And this stands for standard character output stream. It's a way to send text to the output, which is typically on your computer screen. And then after this, I'll do a less than sign, so two of them just like this. And this operator is used to insert or stream the text we want to display. So we are streaming the text hello world to the output. And now after this, I can actually add whatever text I want. So I'll type in hello world. So over here, we have cout, which stands for our character output stream. I also want to tell our compiler or the computer that the line is ending. So I'm going to type in less than sign, and type in standard or std : end L. So this end L just means end line. It's like hitting the enter key on your keyboard. It moves the cursor to a new line after the text is printed. And this is a good habit because it keeps the output organized. And then I will end this line from our code just by simply adding a semicolon like so. If you don't do this, you will probably get a lot of errors. And now in the next line, so I'm going to click enter twice after this, I just want to add a return 0, just like that. So this line, the return 0, it signals the end of the main function. It tells the computer that the program has successfully completed. In C++, returning 0 usually means that everything went as expected and there were no errors. And don't forget this curly bracket at the end. It has to be there to tell us when this function opens and when this main function closes. Because our C++ will look for this main function and everything inside these curly brackets will execute. Great. Now that we understand each part of the code, let's run it and see our hello world message on the screen. So first, let's open our terminal simply by going to terminal. And for me, because I'm zoomed in, I can click on these three dots and hit terminal. You might see it up here naturally. And then we're just going to select new terminal. And after opening our terminal, you might be greeted where it says PowerShell over here. You can just click on this drop down and change it to whatever you prefer. In my case, I'll just be using the command prompt. And in order to run this file, you'll notice that since we already dragged our folder in, it's already going to navigate us to exactly where our file or our folder is, where it says my first program. And from here, I can actually run our C++ file. So now that we're in the correct folder, we'll use the G++ compiler to compile our program. So let's go ahead and type the following command. So I'll type in G++ and then the name of our file, which is hello world.cpp, and then -o, and then I'll type in hello world. And then I'll type in hello world like so. And now after typing G++ hello world.cpp -o hello world, I'll hit enter. So this command tells G++ to compile hello-world.c++ and to create an executable file named hello world. And then I'll hit enter. And if everything's set up correctly, you'll just see it goes to a new line, and just like this. And now we can simply run our program by typing in this hello world we created. So I'll go ahead and type in hello world, and now it'll actually print out the string that we created, hello world, like it says up here. So let's understand the process a little more. By typing in this command, we use the G++ compiler to convert our C++ code into an executable file. Then by typing in hello world, we ran that executable file which displayed our hello world message in the command prompt. And there you have it. You've written, compiled, and ran your first C++ program using Visual Studio Code and the command prompt. And now let's go over basic syntax and concepts. So let's start with one of the most fundamental concepts in any programming language, variables and data types. So I'll create a few examples right under my include IO stream and above my int main. So for example, the data type int is used for storing integers. There are whole numbers such as -3, 5, -3, or 42. And you would define it like this. So for example, int age is equal to 30 with a semicolon at the end. And now let's create a float. And a float is for storing float point numbers, which are numbers with decimals such as 3.14. So I'll go ahead and make a float called pi, which is equal to 3.14. And these age or pi's are actually just the name of the variables that we're assigning using this equal sign to this integer and to this float. And this is the data type we're assigning it to. So a double is similar to a float, but can store double the precision. It's useful for more precise decimal numbers. So for example, double 2 decimal is equal to 5.2999991. And now the data type char is used for storing single characters. So I'll do char initial is equal to r, and this is my initial. And if you want to store a bunch of characters together, you would use the data type called string. And in order to store a string, you would do std, which is standard string, and then I'll do something like the variable name is equal to row. And now we'll also go over a bool. A bool is short for Boolean values, which can either be true or false. So I'll do bool is learning C++ is equal to true. And now let's talk about input and output in C++. To interact with users, we need to be able to display messages and get input from them. This is where the cout and cin come in. So kind of like we created previously. So this line will just print hello world to the console. And this standard : end L is used to insert a new line after the text, just like hitting the enter key. So now what if we want to get the input from the user? That's where cin comes from. And cin stands for character input stream. So here's a good example. So right above my return 0, I'm going to do an std : cout, and I'll just ask the question, enter your age. And then I will do a std cin, and then greater than sign, which will be age. And then up here, I'm just actually going to get rid of all of this. And I'm going to get rid of this hello world line, like so. And you'll see there's a red squiggly line under the age, and that's because we actually need to declare it. So above this std cout, I'm going to do int age, just like that. So what we're doing here is, in this code snippet, we're first going to declare an int variable called age, like so. And then we're going to prompt the user over here to enter their age. And using the cin, the line waits for the user to type in a value and hit enter, and then stores that variable into age. If you see this white circle next to your file, that just means it's not saved yet, and you can head over to File and click Save, or use the shortcut Control Save. So now let's actually try to run this file. So I'm just going to type in that g++ hello world.cpp -o hello world again. And you do need to do this again to refresh everything that's in our main function. So I'll go ahead and click enter, and then I'll just type in hello world, and now it should ask me for my age. So it's going to say enter your age, and I'll do something like 99, and when I click enter, it'll exit out. And now let's do a small quiz. I want you to try to print out our age after we type it in. So take a brief moment and try this out. And you can pause the video here, and I'll get back to you in just a second. All right, let's go over it. So in order to simply print out the age after we type it in, I'm just going to type in std : cout, and then I will type in age, and that's it. So now let's go ahead and actually run this. So I'll just do my g++ hello world.cpp -o hello world, and then I will type in hello world to run this, and it's going to say enter your age, and I'll do something like 300, and then it's going to print out 300 after I click enter. If you got it, let me know in the comments below. And now let's continue. And now let's talk about operators and expressions. Operators are symbols that tell the compiler to perform specific mathematical or logical operations. So some of the most common types are the plus sign, the minus sign, the star or the asterisk, which is multiplication, the slash, which is commonly used for division, or the percent, which is used to get the remainder. So let's write out some examples. So I'll go ahead and erase everything in my main except for the return 0. So I'm going to type in int sum is equal to 5 plus 3. And now I just want to print the sum out like so. So when I go ahead and actually just test this out, it should just print out 8. So relational operators consist of equal equal, question mark equal, which actually means not equal to, less than sign, greater than sign, less than equal to, and greater than equal to. So let's go ahead and go over a few of these. So I'll go ahead and delete the sum that we created earlier. I'll just do something like int a is equal to 10 and int b is equal to 3. And I also want to get the int sum of a plus b, like so. So I want the bool, which is going to be a variable called result, is equal to if a is greater than b and b is greater than 0. So the Boolean result is going to be equal to if a is greater than b and b is greater. So let's go over what this does. So if int is equal to a and b is equal to 3, then the sum will be 13. And the result is going to be if 10 is greater than 3 and 3 is greater than 0. And since both of these are true, then the bool result will print out true. So let's just print out the result. And if I were to just hit save and then compile this and then actually run that hello world, it will print out 1, which stands for true. So true is represented as 1 and false is represented as 0. And now you're probably wondering why this is constantly getting messy and I keep going back and forth. And one thing in order to enhance coding experiences for you and your peers is using something called comments. Comments will help increase code readability. So they're basically just lines in your code that are not executed. They're meant for us humans to read and not the computer. So let me show you a few outside of the main function. So under here, I can type in // and you'll see it turn green. This is a comment. This part will not be executed by our program, and this is only for us to read. And this // is a single line comment. Basically, if I typed here, then you'll see that it's not in green anymore, and this is no longer a comment, and this will give me errors. But if you wanted to do a multi-line comment, you can do /*, and it'll automatically close it with an asterisk slash afterwards, and you can insert as many lines as you want here, as long as it's in between this and this. And using comments effectively can make your code much cleaner and easier to maintain. So now I'll clean everything out from my hello world.cpp, and I actually just want to restart this file from scratch. Starting off, I'll do a hashtag include iostream for our input output, and I'll comment this, and this will just say include the input output library. And then I want to create that int main function, which our compiler will look for and execute everything inside of these curly brackets. First, let's go ahead and declare a variable to store the age. So I will do int age like so. And now let's ask the user for their age. So we're going to type in standard or std cout, and then we'll be asking them enter your age like so. And then we'll take an input from them simply by doing the stdcin, and we'll get age. So this will store the input in the age variable. And then we just need to return 0 to tell our program to end the program, like so. And now let's actually run this. So we'll run this simply by typing in g++ hello world.cpp -o, and then we'll call this hello world. And then I'll click enter, and with no errors, this will just go to a new line, and then we can just type in that hello world. And it'll print out enter your age, and I'll do something like 300, and that's it. And just like we went over our quiz, we can go ahead and just print the age out simply by doing an std cout age. Instead of retyping this entire line, while I'm clicked into my terminal, I can hit the up arrow to just go back. And you can hit it multiple times. It'll just keep going back to whatever you typed in previously. So I'll just type this in, hit enter, and then I'll hit the up arrow again, and then I'll hit the down arrow actually to go back to that hello world. So I'll hit enter, and then I can hit the down arrow to go back to the hello world because that's what we typed in after entering this. And then it'll say enter your age, and I'll just write 30, and then it will print out 30 like so. And that covers our basic syntax and concepts. And now let's get into control flow. So I'm going to click on this double folder icon just to hide my Explorer like so. And I'm actually going to just delete everything except for the return 0 in my int main. So let's start with conditional statements. These let us make decisions based on our code on the conditions that we define. The most common conditional statement is the if statement. So while I'm in my int main, we're going to declare an integer variable called age and set it to 20, simply by typing in int age is equal to 20. And now let's make an if statement that checks if the age is greater or equal to 18. If it is, then the code inside the curly braces runs and prints you are an adult. So for example, we'll start off with the keyword if, and then we're going to check for age if it's greater or equal to 18. And then I'll have open curly brackets, and inside these curly brackets, we're just going to print out a simple you are an adult. And then I want to end this on a new line, so I'll do std end l for end line, like so. And if I go ahead and actually just run this, then it's going to print out you are an adult because we set age to 20 and that is indeed greater or equal to 18. So what if we want to handle different cases, like if the person is a minor? That's where else if and else comes in. So let's expand this example. So after this curly bracket, I'm going to type in else if, and then age is greater than 12. Then we're just going to do a simple print with the standard cout. You are a teenager. And then we'll end this and bring this to another line like so. And this covers our else if. And if neither of these two are true, then we can check the final one with an else. So else, and we don't need a condition here because basically if age is not greater or equal to 18, and if it's not greater than 12, then it will always execute the third line. If these two are false, it will execute this else. And we'll do a simple print using the standard cout. You are a child, like so. So I'll go ahead and hit Control Save to get rid of this dot icon, which means we have changes that need to be saved. And I will just go ahead and rerun this. So I'll type in hello world, and it's going to say you are an adult because our age is set to 20. But if I set this to something like 2 and rerun it, then it's going to say you are a child. And we can even expand on this by getting the input from the user. So now let's ask the user for their age, and then it will automatically print out one of these. So up here where it says int age is equal to 20, I'm going to get rid of this equal to 20 and just declare it as an integer with nothing initialized just yet. So int age, and then we're going to do a standard cout to ask the user for their age. So I'm going to type in enter your age like so. And then we'll get the input by simply doing a standard cin, and this will point to our age variable like so. And then I'll hit Control Save, and I'm going to recompile our script, and then it's going to ask for my age down here. So I'll do something like let's do 17, and then it's going to say you are a teenager. And if I were to run it again and do 30, it'll say you are an adult. Run it again and I select 5, it's going to say you are a child. So another way to handle multiple conditions is the switch statement. And this is useful when you want to compare the value of a variable against several specific cases. So I'm going to erase everything except for that return 0 inside my int main. And now let's do something like a day of the week example. So for example, I'm going to do int day is equal to 3. And I'm going to create a switch which will take in the value of day, and then I'll open curly brackets. And in our curly brackets for the switch day, we're going to make several cases. So we'll have a case 1 that's going to print out Monday. And then we're going to break to actually get out of this case. So essentially, when it checks for case 1 and if it's true, it will print out Monday and then it will break and leave this entire switch. And now I want to make another one for case 2. So I can actually just copy paste this just to make it easier a few times. And then I'll change it from case 1 to 2. And I'll go 1, 2, 3, 4. I'll actually just go to 3 like so. And then I'll do Monday. And then this one will be Tuesday. And this one will be Wednesday. And then after the final break, I'm going to add this default key. And the default will just say, so if it's not case 1, 2, or 3, then it's just going to print out invalid day. So if we were to run this, because day is 3, it's actually just going to print out Wednesday because our case is equal to 3. If no cases match, the default block runs, which will print invalid day if none of the conditions match. So let's go ahead and save this and try this out. So I'm just going to run that G++ line, and then I'll type in hello world, and it's going to print out Wednesday. And if I were to change this to 4 and rerun it, and now it's going to print invalid day. And now let's move on to loop. Loops are used when we want to repeat a block of code multiple times. There are 3 common loops in C++, the for loop, the while loop, and the do while loop. So let's start off with the for loop. So I'll erase everything in my main function, like so. And the for loop is great when you know exactly how many times you want to repeat something. So let's make a simple script that's just going to iterate through integers. So we'll type in the keyword for, and we're going to create an integer, which is going to be integer I, and then we're going to equate this to 0. So we initialize I to 0, and the loop will continue while I is less than 5. And then after each iteration, I is going to be incremented by 1 simply by typing this I++. And then I'll have some curly brackets so we'll know what to do during this function. So we're just going to simply print out the word iteration and the value of I during that loop, and then we will end the line like so. So this loop will run 5 times, printing iteration 0 through iteration 4. So let's go ahead and try this out. So I'll type in that G++ script and then hello world, and it's going to say iteration 0, 1, 2, 3, 4. And the reason why is because we did I less than 5 and not I is less than equal to 5, and we're starting off with int I is equal to 0. So int will be I, and it will check if, so int I is equal to 0 from the start because we initialized it at iteration 0. And it will run the loop and then it will add it by 1 using this I++ method. And now let's create a while loop. So I'll get rid of this for section and I'm going to initialize int count to be 0. And let's make a loop that will keep running as long as count is less than 5. So we're going to type in the keyword while count is less than 5 and then open curly brackets. And then we're going to simply print out count is, and then I'll add a space. And then we're going to get the variable count and then we'll end the line here. And then after this, I'm going to add count by 1 simply by doing count plus plus. So let's go ahead and save this and run this. So inside the loop, we print the value of count and then increment it. Once count reaches 5, the condition count less than 5 is false and the loop stops. And now let's go over a do while loop. So I'm just going to erase this and initialize int number is equal to 10. And then I'll start with the keyword do and then open curly brackets. And in this one, we're simply just going to print out number is, and then we're going to get the variable of that number that we initialized, and then we will end the line here. And now instead of a number plus plus, we're actually going to do a number minus minus. And you're going to see that I'm still getting an error on return, and that's because we actually need to set the condition with the while statement. So after the curly bracket ends, we're going to type in while number is greater than 0, like so, and our errors will go away. So I'll hit save and run this. And in this case, the program will print out number is 10 and then decrease the number by 1 as we stated here. And it will keep doing so as long as number is greater than 0. Even if number started out greater than 0, the code inside the do block will run once before the condition is checked. And sometimes you need more control over how your loops behave. And that's where the break and continue keywords come in. So let's go over the break statement. So let's create another for loop using the int I is equal to 0. And while I is less than 10, we are just going to add I by 1 using the I++. And now inside the curly brackets, I'm going to add another if statement, which is going to say if I is equal to 5, then add another curly brackets, and we can just type in break. And after this if statement, where I is equal to 5, I'm just going to print out std cout I is equal to, and then we'll get the value of I, and we'll end the line there. So now if I were to actually run this code, it's going to give me 0, 1, 2, 3, 4, and it's going to break at 5. And if we were to change this to continue, so change this from break to continue, this statement just skips the current iteration of the loop and moves on to the next one. So let's go ahead and rerun the code after changing break to continue. And now it's going to print out 0, 1, 2, 3, 4. It's going to skip over 5 and go to 6, 7, 8, 9. And that wraps up control flow. And now let's start going over functions. I'm going to erase everything in my int main other than the return 0. Let's talk about what a function is. A function is a block of code that performs a specific task. You define a function once and then you call it as many times as you want throughout your program. So let's go ahead and define a simple function that prints a message to the console. So below my int main, I'll create a few lines and I'll just type in void greet, which is going to be our greet function. And the void just means it's not going to return anything. And then in curly brackets, I'm just going to do a simple print out or standard cout, which is going to say hello from the greet function. And then I will just simply end that line like so. So we'll cover return type soon, but because this is a void, it's not going to return anything. And it tells the compiler that we don't expect any result back from the function. And this greet with the 2 parentheses is the name of our actual function. The parentheses mean it doesn't take any inputs right now. So for example, in here, if we were to pass a variable such as age or something, then the greet would look for an age variable and pass it through. But for now, I'll just erase that because we don't have it, we're not passing anything through. And inside the curly brackets, we write the code that runs when the function's called. We're just using this simple print to print out hello from the greet function. And now in our int main, all I need to do is just reference this greet like so, and I can simply just write this in over here. And that's pretty much it. And it makes our main function look a lot more compact and easier to read. So if I were to run this code as is, you're going to see that I get an error. And it says that greet was not declared in this scope. And that's because we need to declare and initialize our greet function. So above my int main, I actually just need to type in void greet, and this will serve as our function declaration. And then over here, when we call greet again, this will actually be calling the function. And down here is our function definition. So now if I were to try to run this, you'll see that it says hello from the greet function. So the reason why we put this void greet above our main is because it tells the compiler, hey, there's a function called greet somewhere in the code, and then we'll call it in the main function and define it later in the code. Function declarations are useful when you want to organize your code and make sure the compiler knows a function exists before you actually define it. And since this is a smaller program, I can simply just erase this greet up here, the function declaration, and move this entire int main function below this void greet. And then I can simply just recompile and run this hello world and it'll work exactly the same. So the reason why you may want to leave your int main at the very top is because when you are working with much larger files, usually these functions will come from a different file altogether. For the purpose of this tutorial, you can go with either way you want. So now let's make our functions more powerful by giving them parameters and return types. Parameters are values that you pass to a function, and the return type tells us what kind of value the function will send back. So let's create a small function, and I'll just simply erase the void greet stuff, like so. And above my int main, I'm simply going to have another function, which is going to be int add, and we're going to pass in two variables, int a and int b. And then we're going to return the value or the sum of a plus b, like so. So our function that we created is the add function, and it's going to take our two parameters int a and int b. And I can actually define the values of these whenever I call this function. So for example, in my int main, I'm just going to look for that int result, which is going to equal to the add function of 5 and 3. And then I'll simply just print this out by using the standard cout, and I'll type in the result is, and then I'll print out the variable of that result, and I'll end the line here, like so. And then I'll simply just recompile and run it, and it's going to say the result is 8. So we call this add function that we declared up here, and we're passing in the values 5 and 3, which are the a and b in this case respectively, and we're going to return 5 plus 3, which is going to be 8, like so. And now let's talk about scope and lifetime of variables. So scope refers to where a variable can be accessed in your program. The lifetime of a variable is how long the variable exists in the memory. So in C++, there are two main types of scope, local and global. So let's create an example with a local scope. So I'll go ahead and erase everything in my int main and also delete this int add function. So below my int main, I'm going to create a void function. I'm going to create a void my function, which will have an int local variable, and I'm going to equate this to 10. And then I'm just going to simply print out local variable in quotes as a string, and then I'll get that variable that I created called local variable here, and just simply print this out, and then I'll end the line here. So here, local variable is only accessible inside this my function. If you try to use it outside the function, you'll get an error because its scope is limited to this function, since we declared it only within this function. So now let's take a look at global variable. So we've already done this unintentionally in our previous examples, but let's go ahead and go over this. So I'm going to create an integer called global variable, and I'm going to equate this to 20. And inside our int main, I can simply print this out, global variable, and I can actually get the value from inside our integer main. And then I'll end the line here, return 0. And I had a misspelling. I put count instead of cout. Make sure your spelling is correct. And then I can simply just print this out. And here, global variable is defined outside of our main function. So it has a global scope and can be accessed from anywhere in the program because we assigned it outside of our function. So the lifetime of local variables is limited to the function they're in. Once the function is done, the variable is then destroyed. Global variables exist for the entire lifetime of the program. And now let's talk about recursive functions. A recursive function is a function that calls itself. This is useful for solving problems that can be broken down into smaller, similar problems, like calculating the factorial of a number. So let's create a simple example of a recursive function that calculates the factorial of a number. So I'll erase everything just to make it look more readable, and then I'll create a function called int factorial. And this factorial will pass an integer called n, and we're going to say if our n is equal to 0, so basically if this part is true, then we're going to return 1. Else, we will return n times the factorial, and we'll pass in the n minus 1. So we created this function called factorial, which calls itself. The base case is when n is 0, in which case it returns 1. Otherwise, it returns n multiplied by the result of factorial n minus 1. Let's see how to call this in our main function. So first, I just want to initialize this function above our main, like so. And now in our main function, I'm going to create an int number is equal to 5. And then I'm going to call int result. I'm going to create a variable called result, and this will be the factorial of number. And now I just want to simply print this out by typing in standard cout, and then in quotes, I'll type in factorial of, and then I'll get the number, which is going to be 5 in this case, is, and then we're going to print out the result. And then I'll just simply end the line here, like so. And now when I actually run this code by simply compiling it, and you'll see that when I run this, this will actually give me an error. And that's because our int factorial function over here does not match the one down here. So I'm just going to copy this int n and pass it into the top one. And now if I try to run this, it'll work. And it'll say the factorial of 5 is 120. So let's go through what happens. So when you call factorial of 5, the function will keep calling itself with smaller values. So it's going to do 5 times 4 times 3 times 2 times 1 until it reaches the base case. And then it's going to return the result, and the output of factorial of 5 will be 120. And that covers functions on this tutorial. And now let's get started with arrays and strings. So what exactly is an array? An array is a collection of elements of the same type, stored in contiguous memory locations. Think of it like a list of items where each item can be accessed by its position and index. So let's make an example of an array right now. So I'll create a line that declares an array called numbers by typing in int numbers, and I want to tell it that it can hold 5 integers, and I'll just go up by every 10, and the values inside the curly braces are the elements of the array. So I'll do 10, 20, 30, 40, and 50, like so. So each element in the array can be accessed using an index starting from 0. So for example, in my int main, if I wanted to just print out the first element, I would do a simple print first element, and then I would call the numbers array and the index it's at. So in order to print out 10, I would call numbers 0, and then I'll just do an end line over here, and make sure you don't write count, just cout over here. And then I can just copy this line, and I'll change the first to third, and then I'll just do numbers, and the third number will actually be an index of 2, because it does start at 0, 1, 2, 3, 4, like so. And now if I were to actually run this, so I'll do my g++ command, and then I will run hello world. It'll print out first element 10, because this is at the index of 0, and then the third element is 30, which is at the index of 2. So let's explore single dimensional arrays a bit more. You can also declare an array without initializing it right away, and then assign values to it later. So in this example, I'll create an array called grades that can hold 3 integers. And then we can assign values to each element one by one using their index. So for example, I'll do grades of 0 at the index of 0 is going to be 85. And then I can also do grades at index 1 is equal to 90. And then grades at the index of 2 is going to be 95, like so. And you can also loop through arrays to access or modify each element. So let's make an example using the for loop we learned in the previous example. So I'll create a for int I is equal to 0, I is less than 3, I++, and then inside my curly brackets, I'm just going to do a print, which is going to be the grade, and then I'll print out the I plus 1, and then I'll do a colon with a space, and then I'll print grades, and then in this bracket, I'm just going to type in I, because I is what's going to be looping up, and I'll end the line here. So like so. And then we can try running this. And after running it, I'll get grades 1 is 85, grades 2 is 90, and then grades 3 is 95. So the reason I did I plus 1 is because our index does start at 0. And if I didn't do that plus 1, then it would look a little odd and not very user friendly because then it would say grade 0, 85, 1, and 2, when we actually just want it to say 1, 2, and 3. It's just more readable for the user. And now let's talk about multi-dimensional arrays. So these are arrays within arrays, and they're useful for storing data in more than one dimension like a grid or a table. The most common is a two-dimensional array. So let me show you an example of what a two-dimensional array looks like. So up here, I will create a 2D array that represents a 3 by 3 matrix called int matrix, and I'm going to assign it to have 3 elements in each row, and then I'm going to do another bracket with 3 in it. And these two just represent one is for the row and one is for the columns. And then I'll open the curly brackets up and I'll do something like 1, 2, and then I'll have a comma after the curly bracket, and then I'll do it again because we want it to be 3 by 3. So I'll do 4, 5, 6, and then a comma, and then 7, 8, 9, just like so. And don't forget, you will need a semicolon after your curly bracket at the end here. So I'll hit Control Save, and now let's try to print them out. We can access individual elements like so. So I'm just going to do a simple print. So for example, if I wanted to print out element at row 1, column 2, then I would just call the matrix variable, and then I would do 0, and then another bracket with 1, like so. Because this would be the first row, which is 0, and then the second column, which is 2, and then I can just end the line here, and I'll run it again, and we would get element at row 1, column 2 is 2. And now let's switch gears and talk about strings. A string is a sequence of characters, and in C++, we can work with strings in two ways, using character arrays and using the string class. Let's start with character arrays. So let me first show you how to declare a character array that holds a word. So I'm going to type in char name, which will have 6 elements in it, LLO, and then I'm going to actually do a backslash 0. And notice this backslash 0 at the end. This is the null terminator, which marks the end of the string in C++. So we can print out the entire character array like this. So in our main, I'll just do that simple print, and I'll type character array with a colon and a space, and then I can just print out name like so. And now when I actually run this, it'll say character array hello to the console. Using character arrays is a bit tricky, so C++ provides the string class, which makes working with strings much easier. And here's how we declare a string. So I can simply just do a standard string greeting is equal to hello world. And I'll go ahead and erase the character array. And this line with the string greeting is much simpler than character arrays. You don't need to worry about the null terminator, and you can easily manipulate the string using built-in functions. So for example, here's how we can print out the length of the string. So I'll just do a standard cout, and then in quotes, I'll just type in length of greeting, and then I can actually just get the greeting dot length, and then I'll end the print here. And now when I go ahead and print this out, it'll say length of greeting is 12, specifying that hello world has 12 characters in it. Let's explore a few more common string operations using the string class. So you can combine or concatenate two strings like so. So I'll do the standard string, and I'll call this variable first name is equal to code, and then I can do a standard string last name is equal to row. And I'll actually add a middle name and call this with, just to get my full username like so. And now I can just make another variable called full name is equal to, so I can do first name plus quotes with a space in it plus middle name, and then I'll add quotes with a space in it again, and then plus last name, and like so. So we can use the plus operator to concatenate the first name, middle name, the first name, a space, middle name, space again, and last name into full name. And the result will be code with row. So let me go ahead and print this out. So when I just do a simple cout, it'll say code with row after we print this out. And you can also extract a part of a string using the substring function. So for example, I'll make a string called sentence, which is going to say C++ is fun. I can make a new variable called word, and I'll do sentence dot substring, and I'll just do 0, 3. And this extracts 3 characters starting at the index of 0, giving us C++. So when I go ahead and just print this out, it'll just print out C++ like so. You can find the position of a character or substring within a string using the find function. So for example, let's create a string called text, and this text will simply just say hello world. And I'm going to do int position is equal to text dot find, and we're going to find world. And now if I were to print out position, and I'll run the compiler, and it's going to print out the number 7. So this finds the starting position of world in the string and stores it into position. If world starts at index 7, position will be 7 like so. And that's it for arrays and strings, and let's head over to pointers and references. And now let's jump into pointers and references in C++. This is a fundamental concept for understanding how memory works and how to manage data efficiently in your programs. We'll cover pointers, pointer arithmetic, references, passing by value versus reference, and even dynamic memory allocation. So let's go ahead and get started. So before we dive into pointers, it's important to understand memory in C++. Memory is where data is stored while your program runs. Memory is divided into different regions, the stack and the heap. So the stack stores variables with a fixed size like integers, while the heap is used for dynamic memory allocation when you don't know how much memory you need ahead of time. So let's start with pointers. So a pointer is a variable that stores the memory address of another variable. Instead of storing a value like 42, a pointer stores the address of where that value is located in the memory. So let's try to declare some above the main so I can show it. So I'll do int number is equal to 10, and this is just a regular integer variable. And then I'll do an int star, and the variable pointer is equal to and number. And this is a pointer to the integer. So this number is a regular integer variable, and pointer or PTR is the pointer that holds the address of number. And the and symbol is the address of operator, which gives us the memory address of number. The star symbol before the pointer over here indicates that pointer or that PTR is a pointer. To access the value stored at the memory address the pointer is pointing to, we use the dereference operator, the asterisk, and here's how. So in the main function, I'm just going to do a standard cout value of number, and I'll just call that variable PTR with a star, and then I'll do a standard end line. I actually need to put the star before this pointer like so, and then I can simply just compile this, and then I'll run my hello world, and it'll say value of number is 10. And if I get rid of this, then it'll just store the address and not the actual value. So if I were to compile and run this again, it'll say the value of number is this OX7FF blah blah blah. And now let's talk about pointer arithmetic. With pointers, we can perform arithmetic operations to navigate through memory locations. This is especially useful with arrays, and let's go ahead and see how this works. So I'll go ahead and erase this, and I'll change the int number to numbers, and I'll assign these 10, 20, 30, and 40 like so. And then I wanted to do int pointer is equal to numbers. And this is just a pointer to the first element of the array. And now let's print these values out using pointer arithmetic. So in my main, I'm just going to do a standard cout, which is going to say first element, and then I'll grab that pointer and do a standard end line like so. And then I'm going to add ptr++. And then I'm going to copy this line over and just change this to second element like so. And now let's take a look at what happens. So when I recompile my code and run it, it's going to say first element is 10 and second element is 20. So I'll just comment those here like so. Since we increment the pointer, this will move the element to the next one in the array. So we go from 10 to 20. Now let's look at references. A reference is like a pointer, but it's easier to use because it can't be small. And once it's assigned, it cannot be changed. A reference is an alias for another variable. So here's how to declare a reference. So I'll just do int number is equal to 100, and then I'll make an int and symbol and call this variable ref is equal to number. And this is a reference to number. So over here, ref is a reference to the variable number. And any changes made to ref will directly affect number because they are both referring to the same memory location. So for example, I'll do ref is equal to 200 over here, and then I'll print out the value of number. We're setting this variable ref to 200, and then I'll print out the value of number and call number, and this should print 200. So let's go ahead and recompile this and try this out, and it'll say the value of number is 200. When you pass variables to functions, you can either pass them by value or by reference. So let's see the difference. So right above my main, I'll actually erase this and erase this like so. And above my main functions, I'm going to create an empty function, void pass by value, which is going to pass in int n, and I'll set n to 50. And when we call this function, it creates a copy of the variable n. Changes to n inside the function won't affect the original value. So now let's pass by reference instead. So I'll do a void pass by reference of int and then and sign n, and open curly brackets and set n to 50 as well. And here we pass the variable reference using the int and sign. And this means any changes we make inside the function will affect the original variable. So let's go ahead and see it in action. So in my main, I'll just set int number is equal to 100, and then I'll call the pass by reference function and pass in number, and then I'll print this out. I'll do a standard cout value of number after pass by reference, and then I'll get that variable for number and end the line like so. So now when we compile and run this, it'll say value of number after pass by reference is 50. And the original number is now 50 because we passed it by reference. And sometimes we don't know how much memory we need until the program is running. That's where dynamic memory allocation comes in. We can use the new operator to allocate memory on the heap during runtime. So let's create another example. So I'll go ahead and delete this. And up here, I'll create an int star pointer or PTR is equal to new int. And this will allocate memory for an integer on the heap. And I'll actually move this into my main over here. And then I'll do a star PTR is equal to 42. And then I'll just print this out like so. And I'll write dynamically allocated value, and then it'll get the variable and end the line. So now when I compile this, it's going to print out dynamically allocated value is now 42. And then after using the dynamically allocated value, we should free it using the delete operator to avoid any memory leaks. So under this, I can do delete PTR like so. And this releases the memory back to the system. Always remember to delete any memory that you allocate with new. So now let's take a look at the new and delete arrays. If you need to allocate memory for an array, you can use the new with brackets at the end to dynamically allocate memory for multiple elements. So let's create an example. So let's start off by creating an example. So I'll create int with an asterisk at the end and call this variable array. It's going to be new int, and we're going to allocate memory for an array of 5 integers. And then I'll call array at the element of 0 to be 10, and then array at the element of 1 to be 20, and go up until I have 5 values. So array 0 through 4. And then I'm simply just going to do a standard cout and call my first element at the array at 0 and end the line. We use the new with brackets to create an array dynamically. And after we're done using the array, we have to free the memory using the delete key. So after this is done, we can just use the delete and then with empty brackets at the end and call the array variable like so. And this will free dynamically allocated array. This ensures we don't waste memory or cause memory leaks by forgetting to release the allocated space. And that covers pointers and references, and now let's get into object-oriented programming. Now let's dive into one of the most important concepts in modern programming, object-oriented programming. So object-oriented programming helps us write cleaner, more organized, and reusable code. In this module, we'll cover key object-oriented programming concepts like classes, objects, encapsulation, inheritance, polymorphism, and more. We'll also define and use our own classes in C++. We'll also look at constructors, destructors, and member functions work. Let's jump right in. So what exactly is object-oriented programming? Object-oriented programming is a programming paradigm centered around objects rather than functions. An object represents a real-world entity, and classes are blueprints for creating those objects. They help you organize your code by grouping related data and behavior together, making it easier to manage complex programs. So let's go over encapsulation, abstraction, inheritance, and polymorphism, and we'll break them down one by one as we code. So first, let's start by defining a class. So I'll actually do this above my int main, and I'll create a class called car. And I'll add that semicolon at the end of this. And a class is like a blueprint that defines the properties, in this case it's going to be our variables, and behaviors or functions of an object. So let's see how to create a simple class in C++. So in this class car, I'm going to create 3 variables. And before creating our variables, I'm going to type in public. And this public means that these variables and functions can be accessed from outside the class. So after the public, I'm just going to create a string called brand, and I'll also create a string called model, and then I'll create an integer called year. And now I'm just going to do a simple void print details, which is our function, and this function will print out the brand, the model, and the year, like so. And now let's create an object of the car class and use it in our program. So let's create an object called myCar of the class car. So I'll do car myCar because my car is the variable. And now we're going to assign the values to its attributes, brand, model, and year, like so. So I'll do myCar dot brand is equal to, I'll do something like Toyota, and then I'll do a myCar dot model is equal to Corolla, and then I'll do a myCar.year is going to be 2020. And now I can just call the print details function that we created up here. And I'll do a myCar.year is equal to 2020. Now I can just call the myCar.print details like so. And now when I run this code, it'll say brand Toyota, model Corolla, and year is 2020. And now that we've seen how classes and objects work, let's talk about encapsulation and abstraction. Encapsulation means wrapping data and the functions that operate on the data inside a class. It hides the internal details and protects the data from outside interference. So let's modify our car class to use encapsulation by making the member variables private and providing public getter and setter functions. So over in my class car, I will change this public to the word private. And now under my int year, I'm going to create a public section. And in this public section, we're going to create a function called void set details. And this details will just pass in a string b, string m, and int y to represent brand, model, and year. So I'll do brand is equal to b, model is equal to m, and year is equal to y, like so. And now the data members brand, model, and year are private, meaning they cannot be accessed directly from outside the class. Instead, we provided this set details function to set these values. This ensures our data is protected and accessed in a controlled way, which is part of abstraction, hiding unnecessary details from the user. And now when I scroll down, you'll see that it says mycar.brand is now inaccessible, and same with model and year. So I'll go ahead and erase this. And now let's talk about inheritance and polymorphism. So inheritance allows one class to inherit properties and behaviors from another class, making it easier to reuse code. The class that inherits is called the derived class, and the class it inherits from is called the base class. Let's create a sports car class that inherits from the car class. So under my class car, it ends over here. I'm just going to go down a bit and create a class sports car, and then I'm going to do a colon public car. And I'll make a public keyword, and inside I'll declare a variable called max speed. And then I'm just going to do a print. I'm just going to create a function to print the max string. And then I'm just going to create a function called void. And then I'm just going to create a function called void print speed to just simply print out the max speed, like so. So here we've declared that sports car is a derived class, and it inherits all the properties that car has, such as brand, model, and year. We also added a new property called max speed and a function called print speed to display the car's maximum speed. And now let's see how we can create a sports car object and access both the inherited and the new properties. In my int main, I'm going to create a sports car object, which is going to be called my sports car, like so. And now I'll grab the set details function. So I'll do my sports car dot set details, and I'll just do something like Ferrari, and then I'll do a 488, and I'll do the year 2020, like so. And then I will set my sports car dot max speed is equal to 210. And now I can call the my sports car dot print details function and the my sports car dot print speed. And now when I go ahead and actually run this, it'll say brand Ferrari model 488, and the year is 2022, and the max speed is 210 mph or miles per hour. And this brings us to polymorphism, which means many forms in object-oriented programming. It allows us to use a base class pointer or reference to call derived class methods. So we'll also see how polymorphism works when we discuss virtual functions. And now let's talk about constructors and destructors. So a constructor is a special function that is automatically called when an object is created. It's used to initialize the object's attributes. A destructor is called when an object is destroyed and can be used to clean up resources. So let's go ahead and add a constructor to our car. So right under this public, I'm going to create a constructor, which is going to be car, and it'll pass in the string b, string m, and the int y. And I can just copy this brand equals b, model equals m, and year equals y in here, and erase it from my set details. I can actually erase the entire set details function like so. So this line where it says car, string b, string m, int y, this is going to initialize the car's brand, model, and year. And we can now create a car object with these values. And here's how we can use the constructor in main. So I'm going to head back to my main. I'm going to get rid of all of this. And in my main function, I'm going to call in car, my car, and I'll do that Toyota, and then in quotes, I'll do Corolla, and then call that 2020 year, like so. And then I'll do my car dot print details, and that's all I need. And now when I actually run this, it'll print out exactly what we put in. So when we create the my car object, the constructor is automatically called, and the car's details are set. The destructor is called when the object is destroyed, and will typically define it to free resources or perform cleanup tasks. It's declared with a tilde symbol before the class name like so. So I'll scroll up to where my constructor is, and on the left of your 1 key, hold shift and click that button to call the destructor class like so. And now in my car class, under my public, under the void, I'll just do a shift tilde, and then I will call the car function, and then I'll do a simple print string, a simple standard C out the console, which is going to say car object destroyed. And then I'll hit save. And this destructor will automatically be called when the my car object goes out of scope at the end of the main function. So let me show you an example. So I don't need to actually call this, it'll automatically be called when it leaves the scope. So if I were to compile this and then run my hello world, it's going to say car object destroyed right after it already brings it and leaves the scope. Sometimes the derived class needs to provide its own implementation of a function that exists in the base class. This is called overriding. To make this work properly, we use virtual functions in the base class. Virtual functions allow derived classes to override functions while still being accessed through a base class pointer. So let's modify our car class to include a virtual function that we can override in the sports car class. So for the print details, I'm just going to write virtual right after this void. And I'm going to change this string just to simply say this is a car, like so. So here we use the virtual keyword to make the print details function virtual. This allows derived classes like sports car to provide their own version of the function. And now let's override print details in the sports car class. So when I scroll down, I can call this function called print details simply by typing in void print details, and then I'll add the override keyword afterwards and open up my curly brackets. And then I'll simply just copy paste this string and change it a bit. So instead of this is a car, I'm going to change this to this is a sports car. And I can hit save from here. So now in the sports car class, we override the print details function and provide a different message. Notice the override keyword, which makes it clear that this function is overriding a virtual function from the base class. So let's see how we can use this in our program. So down in our main, I am just gonna call car with an asterisk, and then the variable will be car ptr is equal to new sports car. And now I'm gonna use car ptr and then a dash arrow sign going to the print details function. And this calls the overridden function in sports car. And then afterwards I can delete car ptr, and this will just free the memory like so. And when you hover over this new sports car, it's because we don't have a constructor for sports car. So let's go ahead and create that. So under the sports car, under my max speed, I'm just going to create a constructor for sports car that calls the car constructor. So I'm going to type in sports car, and then I will do the string b, string m, int y that we have set up here, like so. And then I'll also do an int speed for our max speed. And then I will do a colon car b, m, y. And then I'll do a comma and call the max speed, which is going to be speed. And I'll do an open and close curly bracket, which calls the car constructor and initializes max speed. So I'll leave a comment on the side over here, just like that. And now I also want to create a destructor for the sports car. So I'll do tilde key, sports car, and I'll do a simple string saying sports car is destroyed. So with the C out and in quotes, sports car object destroyed and end line. And now I want to provide the arguments down here for our new sports car object. So I'm going to type in Ferrari 488 and the year will be 2022 with a max speed of 210. And now when I go ahead and run this script and print it, it's going to say this is a sports car, and then it's going to destroy it after this delete function gets called. And that wraps up our introduction to object-oriented programming in C++. Thank you so much for sticking with me through the C++ journey. We've covered some pretty important concepts. Remember, programming is all about practice, so keep experimenting, building projects, and challenging yourself with new problems. If you enjoyed this video and want to see more content like this, don't forget to subscribe and hit that notification bell so you don't miss out on future tutorials. Your support really helps the channel grow and it means a lot to me. Feel free to check out my Patreon and join my Discord if you have any questions or just want to support my channel. Thanks for watching. Can't wait to see you in the next video. Happy coding, and thanks for watching Code Throw.